Okay, so we are going to determine if our function f of x has an inverse. And we can do that graphically. So we're just going to go and graph this like we normally would. So it looks like there's a vertical stretch by a factor of 2, and there is a horizontal translation 3 units left. So I'm going to do, let's make a coordinate grid that looks like this. This should work out okay. And our vertical asymptote will be at -3, 1, 2, 3. And because there was no k translation, vertical translation, our horizontal asymptote is just the x-axis. Okay? So from there, we're going to make our table. Again, we've taken care of our translations. So in other words, this is now gone. So I'm going to be making a table for 2 over x. I'm going to fit this right here. So first thing I'll do is I'll just do my parent function, which as we know is just this. And then I'm going to be taking my outputs and multiplying them by 2 in this case. So I'm going to use my normal numbers. I'll use -2, -1, 1, and 2. So plugging those into my parent function, I get -1/2, -1, 1, and 1/2. And then multiplying all those y values, because these were the y values, by 2, I'm going to get -1, -2, 2, and 1. Again, we've done this plenty of times at this point. Let's go and graph what we got. So I've got the point -2, -1. Again, I'm treating this like my origin. So -2, -1 is right here. -1, -2 is here. So hug, horizontal asymptote, hug, vertical asymptote. Then for the other side, for the other branch, we've got the point 1, 2 and the point 2, 1. Okay, so there's our graph. If we want to determine if the inverse of a function is itself a function, we do the horizontal line test. Here's what the horizontal line test. When you have a graph, you just start looking at your horizontal lines. If, you notice if I'm drawing my horizontal lines, if any horizontal line touches the graph more than once, then it's not, then the inverse of this is not a function. But notice every single time I touch, one place, one place, one place, one place, one place. So this function has an inverse. Just really quickly, let's pretend really quickly there was a little difference to this graph. Let's pretend the graph kind of looked, I'm going to do this in a highlighter. I'll do it in red. Let's pretend the graph also looked like this. There was this other weird branch right here. Notice applying the horizontal line test. Touches here, touches here. It's touching in more than one place, therefore it doesn't have an inverse. The inverse is not a function, excuse me. That being said, I'm not too worried about the inverses. I want to focus instead on how to find the inverse. Okay, how to find the inverse. So let's go and do that. So we're going to do the same stuff we've done before. What we've done before is we've turned f of x into y. Then in order to take the inverse, we picked up x, we picked up y, and we switched them. We literally, if we could pick them up, we would. So we get x equals 2 over y plus 3. From here, we just solve. Okay, we're just going to solve. So I want to solve for y. So I'm going to get x times y plus 3 equals 2. So I cleared that denominator on the right-hand side. I'm going to divide both sides by x. So y plus 3 equals 2 over x. And then finally, to solve for y, I'm going to subtract 3. So y equals 2 over x minus 3. So the inverse of that function is just 2 over x minus 3. And that's the big idea here. That's the big